Hello everyone, this is Sum of Products by Prince Sharma. It is basically made of two things, that is sum and product. Here the term sum is interpreted as logical or, and the term product is interpreted as logical and. In terms of electronics, these are the meaning of sum and product. Over the course of this video, we will use multiple terms that are of relevance. First of all, that is canonical form. Like what is canonical or standard form? It is also called minimal form. Also, what is minterm? One more thing is max term, but that is not relevant to this video, hence we are going to focus on minterm only. And there are the basics of Boolean algebra, that is a when high is represented as just a, and a bar is when a is low. That is all. So the sum of product, it is giving us a hint, the name itself, that in this there is going to be multiple terms which are going to be summed, of course, because sum of something is represented by that only. And inside this will be some smaller terms which have product of something, right? So that is where min terms come in. Min terms is exactly what SOP or sum of product is made up of in canonical form. So now we will discuss the term canonical form, minimal form, and min term further. First, let us get into the sum of products using a question. Here we have a truth table. We can see it has three variables. So the number of combination is 2 to the power n, where n is the number of variables. Here 3, so 8 combinations are possible. All 8 are listed down here in this truth table. Now, for representing this f function in sum of product as sum of product, we have to list down the inputs where the function is high, or the function's output is high. So we write down f, then just list down the variables and their state. So a is low, so a bar, then b is high, then c bar because it is low. Then we move on over here. A is high, then b is low, and c is also low. Then further, a is high, b is low, and c is high. Similarly, a, b, c low, and all three are high on last input output. Then a, b, c, simply all three are high. So this equation that we have just wrote down is nothing but SOP of that particular function f, sum of product. And since we just noted down from truth table itself raw, it is the canonical form. A bit more on canonical form. In canonical form, each term that contains the SOP has all the variables of that function. Here f has three variables, a, b, and c. Here we can see all the terms contain all three of the variables a, b, and c, right? But if, for example, I'm saying if a function has two variables and the SOP is written as this, something like this, here we can see this term doesn't contain the all two variables that the function is supposed to have. So this is not the canonical form. Now to touch down on minimal form, we are going to convert this canonical form to minimal. The function just written as SOP. So now for converting it to minimal form, here we can see in just basic canonical form, we have 5 outputs where the function is high, and such 5 terms are present in this SOP form, canonical. For converting it into minimal form, we are going to use basic Boolean algebra. So first of all we can see AB bar, and AB bar is common over here, so proceeding with that, plus A B bar, and inside we are left with C bar plus C. Similarly, in the last terms AB is common, so taking them out, AB, and inside we are again left with C bar and C. We know C bar and C is nothing but 1. Further minimizing it down, A B, A bar B dot C bar plus A dot B bar plus A B. Now we can see A is again common, so F A bar B dot C plus A B bar plus B. This again tends to 1. A bar dot B dot C bar plus A. Now we know whenever something is written as, this is sideline from here, A plus A bar X, we can write it down as A plus X. Hence the function just minimizes down to A plus B C bar, and this right here, my friends, is nothing but minimal form for the SOP of this particular function f. So right here is all the summary. Sum it all up. This is the canonical form which we just wrote down from the truth table, and this, after simplifying it, we got the minimal form. We started from here discussing that sum of product is nothing, logical OR gates and logical AND gates combined. Here is what we saw. The product is nothing but the AND gate, and the sum is nothing but the OR gate, and we combine the both to get the SOP of this function, that is f. Right? Canonical form we already discussed. Now the one thing that is left is minterm. So for discussing minterm, here we go. Minterm is nothing but, see here, the variables are written as A dot B dot C, a product of each other. This is one minterm, right? This is one minterm, this is one minterm, and this is one minterm. I also said max term is something like A plus B plus C. Out of scope of this video, so here we go again. Product, the variables in product A dot B dot C is minterm. In this truth table, we saw the canonical form consists of multiple minterms. So this whole input and output is one minterm, and so on and so forth. They are represented as small m and then numbers, so m0, m1, m2, m3, m4, m5, m6 and m7 respectively. And we wrote down m2, m4, 5, 6 and 7 in this SOP of function f, as they are the only ones high. So another way to represent f is this m, which were those m2 plus m4 plus m5 plus m6 plus m7. Also, one more way to represent it is f ABC, because it is the function of these three variables, the sum sign, and then 2, 4, 5, 6 and 7, right? And this sum sign is not to be confused with our regular sum, rather it is the OR, logical OR. Here, my friends, that is the conclusion of whole SOP, that is sum of product. We started from logical AND OR, canonical form, minimal form, minterm, then representing and doing the exercise with this question. I hope you understand. Thank you. Signing off.